Hi, folks. Joseph Kursky here with you to examine change over space and time with the Wayback Imagery app. This is part of the Living Atlas apps from Esri, and I've had numerous videos, blog posts, lessons based on these Living Atlas apps. Definitely, I recommend you use these for engaged conversations and hands-on inquiry with students to look at air quality, water balance, satellite imagery, which is what we're going to look at today, past and present, looking at changes in the Earth from humans and also from natural forces, and talking about why those forces happen, in what scales and in what contexts. So let's take a look at the Tonga Eruption. All right, in the Wayback Imagery app, which again has multiple terabyte loads of satellite imagery from all over the world. You can use this same app to teach about coastal erosion, deforestation, reforestation, urban expansion, stagnation in population, the construction of dams and reservoirs, glacial retreat, eruptions like this. I don't know of any other app currently that allows you to do so many things with the satellite imagery at your fingertips, but there are certainly no shortage of these things. And this particular example, at the present time, I don't know of any other example that shows how starkly the world is changing. There are many examples out there, of course, that we could talk about, but if this doesn't get the students saying, wow, then folks, I really don't know what would, because this is absolutely amazing. So, okay, on the left-hand side here, I've got the 2014 imagery, okay? So we can see Tonga and Pai here in the South Pacific. Okay, well, where is this located, Joe? So let's zoom out a little bit. Okay, we've got the South Pacific here, and we can see Fiji up there to the northwest. We can see New Zealand to the southwest, Australia out to the west, and so on. Okay, so we've got this particular information at our fingertips. Fascinating to be able to look at these images. So let's go ahead and refresh that so we can see exactly what we're looking at. Now we're going to go and zoom in real tight on this area once again. And we can see in 2014, we've got Pai off to the southwest there, and Tonga to the northeast in 2014. As I scroll to the left, I'm going to see the 2024 imagery, 10 years later on the right side. And so I can see here that, you know, something happened. The islands were fairly large in this image. We can use a measurement tool in another application to figure out exactly how large they were. For example, in ArcGIS Online, we'll have a measure tool, and we can determine that. But the point is here, things have changed, right? The shape has changed, the size has changed. So what happened in between? Right now, 2024, which is about a year ago, as of the time I'm making this video, they are a lot smaller than they were in 2014. Which part of the island remains from before? Interesting. Let's take a look at Tonga. Just a little bit remains. Fascinating. Now, you and I know what the answer is. There was a massive buildup of another island that connected these two things, and then an eruption of that island, which was one of the most recent and largest explosions on the entire planet, having been captured in a visual form by astronauts on the International Space Station. Take a look at that image and show that to your students. But let's take a look at 2018. In 2018, by 2018, between 2014 and 2018, you had an island that appeared here from a series of eruptions that actually joined these two islands. Isn't that fascinating? Look at that. One of my colleagues, Alistair Bonnet, who wrote a book called The World of Islands or The Age of Islands, one of those two titles. Anyways, fascinating book. Went to man-made islands, human-made islands, and natural islands, and actually stood on this ground before the whole thing exploded But take a look at this. You can even see where the crater developed, and these, look at this fascinating landform here. Oh, that's so interesting. Okay, so we had in 2018, the two islands were actually joined. 2019, okay, different time of year, different time of day, different kind of imagery here, but now we've got, let's take a look at, we've got some buildup. It looks like the crater, looks like the land surface is higher in 2018 than 2019 than it was in 2018. Just taking a look at the shadows here and this feature right in here where I'm pointing. It looks like it actually increased. You can see the cliff here by the oceans, another indication. Taking a look at that, go back to 2018. There's a cliff, but then it increased by 29. What about 2020? Okay, interesting. All right, so 2020, it still was there, that island joining the two former and currently existing islands. So what about 2021? Okay, it's still there. Is it any taller? Can we detect any change here? Has the eruption stopped? It looks like there's some incisions there, perhaps some erosion, perhaps the building has stopped on the island. We'd have to do some additional research to find out. Okay, it's still there. Looks like some erosion perhaps is continuing to occur. Those erosional features, those fissures, those rivulets are a little bit bigger. And then 2020, sometime between March 2022 and Jan 2023, the whole thing went sky high. The whole thing erupted, and we are left with these two small bits. Interesting. And it looks like between 2023 and 2024, there's been some erosion in the remaining bits, so that they're even smaller. What about Hunga Tonga is also smaller, and so is Hunga Ha'apai. 2023 to 2024 now. We've got about 11-month period there. Okay, let's take a look at 2023, and over here put 2023 about 11 months later. So now we're looking at, that's the same, even though it looks like the exact same image. So sometimes the image stamp is the region, and it doesn't exactly match the dates on here. So let's take a look at 2023, 1207, and 2024, 1118. Okay, so now we've got a different image, and it definitely looks like those islands are eroding or sinking. So we've got a smaller, what about 2024, 11? Okay, that's what we've got in the right-hand side. So 2020, well, let's recap. 2014, we had this situation. Two islands, both elongated. 2018, an eruption, and again, more research, ideally by students to find out what exactly happened, when did it happen, were there people living there, etc. 2019, 2020, 2021, 2022, and then by 2023, then there was that massive explosion, and that whole thing erupted. So I hinted at, let's go to ArcGIS Online, and let's take a look at maps. So go to arcgis.com, ArcGIS Online Map Viewer. Let's take a look at, do a search for Hunga Tonga, and because of the place names in here, we might not be exactly the one we want. So one thing that would be helpful is if we went to this one and figured out what the latitude and longitude was of this actual location. So looks like this is this location right here. So let's go ahead and see if we can copy that. Looks like we might be able to just highlight it and copy it. Now we'll go to ArcGIS Online. And you see where I'm going with this, right? Because when I typed in the place name, it's not exactly what I want. Why do I know that? Because this is the inhabited portion. We've got an airstrip here and so on. So we can actually search on a lat long. Now, the interesting thing about latitude, longitude in mapping tools, sometimes it's latitude, longitude, like in everyday speech. Sometimes it's longitude, latitude. Sometimes it's degrees, minutes, seconds. Sometimes it's decimal minutes. Sometimes it's decimal degrees. So let's just take a look at if this will work. I think I'm going to need to trim off the Y and put a comma there. And for an X, it's minus because it's Western and it's Southern. So they're both negatives. So that's an important concept to get across. Okay, now if we zoom in here to that same lat long, now we're going to see those two islands that we talked about. Let's change the base map to an ocean's base. It doesn't make any sense to have continuous tone of blue around these two things. So let's change it to the ocean's base map. So now, so we have a variety of base maps at our fingertips. And you know, the ocean's base map makes it a little bit blurry here for the islands. So it makes me suspect that those islands are not captured as a vector, a polygon in this area. So let's go ahead and change it to imagery hybrid for, this looks exactly like the 2024 imagery that we were looking at in the Wayback Imagery. And so now the main point was, what we wanted to get to was, let's get to the measure tools, and we can measure, change it if we wanted to. We could change it to metric if we wanted to. About 1,000 meters, about a kilometer, or 0.58 miles. What about Hunga Tonga? New measurement here. Let's zoom in on that one. Right now, it looks like it's about 670 feet or 207 meters-ish. What about a new measurement for area? What's the area measurement here? 82,000 square feet, 7,600 square meters-ish. Depends on where we actually drop these little points, and you can make it a little more accurate if you want to. But anyway, very interesting that we can now measure these, and then how far are these now apart? To go new measurement, and let's do a linear distance between one of these islands and the other. 1.39 miles or 2,200 meters, 2.2 kilometers. Interesting. So what if we added the clarity layer? Sometimes the clarity is of a different age. And we'll go to ArcGIS Online, clarity imagery. I'm not sure if that's still available in this area. Let's just take a look. World imagery clarity. Okay, there it is. And as I suspected, sometimes that clarity image is a couple years back. And now the fascinating thing is we've got it in ArcGIS Online, and now we could measure this whole thing. Measurement. Let's measure the area. And now look at this. We've got these tools where we can measure this whole combined set of 3 islands. About a square mile and a half or 4 kilometers, 4 square kilometers is what we're getting there. Interesting. Interesting. Fascinating. Oh my gosh, this is so grand that we have this at our fingertips. What about one more thing? What if we put this in the 3D scene viewer? Interesting. Let's try that. I'm not sure if the vector data sets are going to be there, but let's go to ArcGIS Online, and let's go to the scene this time, and let's do a search. Let's get rid of this and do a search on our XY. And once again, we're going to need to trim off those characters. So we just have minus 175, comma, minus 20. And let's zoom there. I'm interested now in if there's any elevation associated with these features. And if so, it would be fascinating to be able to, in the tools, can we get a profile? Yes, we can. Look at that. Interesting. We can get a profile of that island. You can see the number of 80 meters-ish. What about Hunga Tonga? Let's zoom in on there. Interesting. So the point is, folks, that you have a variety of fascinating tools at your fingertips. We started with the World Imagery Wayback, and we also used ArcGIS Online and ArcGIS 3D Scene Viewer for additional insights. And we are looking at a extremely fascinating and grim reminder of our natural hazards that we are living cohabitively with, right? The 8 billion humans that are living with these natural hazards. Wildfires, volcanic eruptions, earthquakes, floods, etc. Let's do one last thing. We've got a video, but also this image of Hunga Tonga Ha'apai erupting as recorded by the International Space Station. And now we've got a little bit more information here too. What we were just actually analyzing inside ArcGIS Online and ArcGIS 3D Scene Viewer. there was damage beyond those particular islands. Where in the inhabited portion of this part of the world, you can see here that homes were damaged, etc., and some human devastation. So that is a grim reminder of why this all matters. 84,000 people, 12,000 households affected. 3 people died, according to this data, and 2 people died in Peru, a long ways from here. We could do a measurement and see how far away those people were. Why? Because of these waves generated by these volcanic eruptions. And one last thing as well, there's this as well. And last bit, we had a suspicion of when this was, 2021. So let's go back to our original 2022, 2021, 2020, 2019, 2018, 2021, and we look at 2022, 2023, the start date, and then you've got a 4 January, end of 2021 to January 2022. And so let's go back to here, keeping in mind that these satellite image dates doesn't mean exactly that every single part of the Earth's surface was captured then. We've got information here on this particular image, as you can see here, captured 2020 as shown in this version of the World Imagery Base Map. So you've got a little bit of a disjointedness between dates. But the point is, we can find out all kinds of interesting and also grim reminders of our dynamic planet with these tools. So I encourage you to use these tools. There's nothing I've signed into. I'm using a web browser with a halfway decent internet connection, and that's all I've got. So powerful tools at your fingertips to explore our dynamic, changing world. Thanks for being with me.